Jamie Spencer. I serve as the feed technical specialist for the Kansas Department of Agriculture, and I appreciate everyone being on here this morning, taking time out of your busy days. Today, we would like to focus this webinar on drug and toxic ingredient carryover in feed. We feel that this is important to KDA license holders, as we've had numerous occasions this past few years of drug and toxic ingredient carryover causing animal illness and deaths. We have some housekeeping items we'd like to cover. First of all, during the presentation of the slides, the participant microphones will be muted during the meeting. If you have questions during the presentation, please submit your questions using the chat button at the bottom of your screen, and KDA staff will be monitoring the chat for questions to be asked at the conclusion of the presentation. Lastly, this session is being recorded and will be posted on our website next week. I would like to introduce our presenter today, Deborah Brazel. She serves as our Dairy and Feed Safety Grant Coordinator at the Kansas Department of Agriculture. Deborah, I will now turn the time over to you for your presentation.
Good morning. My name is Deborah Brazel. I'm the Program Coordinator for the Dairy and Feed Safety Program at the Kansas Department of Agriculture. Today, our Feed Technical Specialist, Jamie Spencer, and I will be covering drug and toxic ingredient carryover, control, and prevention. Over the past few years, Kansas has had an overabundance of complaints and animal deaths due to errors with medicated feed and toxic ingredients in animal food. One case involved a calculation error. 3 cases involved toxic ingredients conveyed into the wrong storage bins. Most of the other cases involved drug or toxic ingredient carryover from an ingredient or animal food that was safe for its intended purpose to an animal food that was adulterated due to the carryover into an animal food for an unintended species. Carryover and cross-contamination of animal food with drugs and toxic ingredients is a major concern among animal food manufacturers, producers, and regulatory personnel. Carryover of medications and toxic ingredients can occur when the substance is transferred from an acceptable location to a non-acceptable location. For example, if it is from an animal food that the substance is acceptable into one that is not, or a piece of equipment to an ingredient or finished feed bin. The transfer generally happens between feed for different species or production classes of animal food that is manufactured using common equipment. An ingredient or feed becomes hung up in the equipment and breaks loose when a subsequent ingredient or feed is introduced. The drug or toxic ingredient is then commingled with other ingredients or feed. Residue versus carryover. We consider residue to be a relatively small amount of contamination that may be left behind in the manufacturing equipment. Residue may be a small portion of the ingredient that may adhere to the equipment as dust through electrostatic adhesion or animal food left behind at the bottom of the mixer, in an elevator boot, or other manufacturing equipment. Carryover, conversely, would be a large amount of feed that might end up in the wrong feed. These two terms will be used interchangeably throughout this presentation. A circumstance where residue could be potentially harmful would be copper in sheep feed. Sheep are especially susceptible to high copper levels, leading to copper toxicosis from excessive copper in sheep diets. Feed ingredients without any added copper could easily have copper levels up to 10 to 15 parts per million. Copper residue from manufacturing equipment not adequately cleaned out could cause copper toxicity in sheep. We have found that a molasses blender that was not adequately cleaned contributed about 5 parts per million to a subsequent feed. At 20 parts per million, some sheep could begin to show signs of copper toxicity, and some may become ill and die. At 40 parts per million copper, many sheep will die. A small amount of residue can have deadly effects. Some of the most common ingredients that can cause toxicosis and death in livestock include, but are not limited to, drugs, especially ionophores, non-protein nitrogen, mycotoxins, minerals, and vitamins. All animal food manufacturers that manufacture with medications are required to follow current good manufacturing practices found in Title 21 Code of Federal Regulations, Part 225. CGMPs indicate that clean out involves all equipment that contacts medicated feed. 21 CFR 225.65 Equipment Cleanout Procedures. For FDA-licensed medicated feed mills, Subpart A is adequate cleanout procedures for all equipment used in the manufacture and distribution of medicated feeds are essential to maintain proper drug potency and avoid unsafe contamination of feeds with drugs. Such procedures may consist of cleaning by physical means such as vacuuming, sweeping, washing, etc. Alternatively, flushing or sequencing or other equally effective techniques may be used whereby the equipment is cleaned either through use of feed containing the same drugs or through use of drug-free feedstuffs. Subpart B is all equipment, including that used for storage, processing, mixing, conveying, and distribution that comes in contact with the active drug component, feeds, and process or finished medicated feed shall be subject to all reasonable and effective procedures to prevent unsafe contamination of manufactured feed. The steps used to prevent unsafe contamination of feeds shall include one of the or more of the following, or other equally effective procedures. 1. Such procedures shall, where appropriate, consist of physical means such as vacuuming, sweeping, or washing, flushing, and or sequential production of feeds. 2. If flushing is utilized, the flush material shall be properly identified, stored, and used in a manner to prevent unsafe contamination of other feeds. Or 3. If sequential production of medicated feeds is utilized, it shall be on a predetermined basis designed to prevent unsafe contamination of feeds with residual drugs. Non-medicated animal food manufacturers must also follow current good manufacturing practices found in 21 CFR Part 507. 21 CFR 507.25 Subpart A5 is adequate precautions are taken so that plant operations do not contribute to contamination of animal food contact surfaces, and animal food packaging materials. Nearly all animal food manufacturers are required to assess the ingredients, processes, equipment, and facilities for risk by performing a hazard analysis to determine the likelihood that a hazard may occur and the severity that hazard may cause if not controlled. There are multiple ways a hazard may be controlled. A hazard may be controlled by using a prerequisite program such as an SOP, which is a standard operating procedure, or good manufacturing practices. A hazard may be controlled using a supply chain control. A supplier may have addressed or controlled the hazard in their plan prior to shipping. An ingredient of feed may have a certificate of analysis from a distributor, or a control may be applied downstream from the manufacturer by another distributor or processor. Some hazards may need to be controlled by a preventive control applied at the manufacturer. Drug carryover is of great concern as the results can be devastating, resulting in sick or dead animals and drug residues in milk or meat products. An example of this is ruminant animal food that is medicated with Meninsen that is carried over to a horse feed. The Meninsen is highly toxic to horses. The LD50 for Meninsen in horses is about 2 milligrams of Meninsen per kilogram of horse body weight. A 1,000-pound horse is roughly 454 kilograms. Multiplied by 2 equals 909 milligrams of Meninsen. If feed contains 300 grams per ton of Meninsen, that equals 150 milligrams per pound, or 900 divided by 150 equals 6. 6 pounds of feed containing 300 grams per ton would kill 50% of the horses that would eat it. In some instances, less than 1 milligram per kilogram could be lethal. That could be 3 pounds to be lethal. The ones that do not die will be very ill. In another scenario, a swine feed containing telmicin could be carried over into a dairy feed and contaminate the milk. Some people are allergic to certain antibiotics. The carryover of antibiotics into dairy feed could cause anaphylaxis in humans, which could lead to death. This is one reason milk processors test milk for antibiotics. Second, the antibiotics inhibit bacterial growth of beneficial bacteria in some of the milk product manufacturing like yogurt and cheese. The antibiotics in dairy feed pose a risk to humans and animals. Drug carryover can occur from all equipment used to mix, mill, hold, convey, or deliver feed. Medications and toxic ingredients should be addressed in the food safety plan at receiving to make sure the ingredients received are the correct concentration or potency. Storage and use of these ingredients should also be addressed in the food safety plan and/or the hazard analysis. Receiving of bulk ingredients could potentially be the first place that toxic ingredients could enter the system and be placed in the wrong bin. Equipment malfunction and human error can be contributing factors that should be addressed in the hazard analysis at this point and every subsequent step in the process. The hand add area or the micro machine are the first place that these ingredients are intentionally introduced to the manufacturing process. Weighing errors build up on the hand add grate, micro machine buildup, or not cleaned adequately could cause the wrong amount of ingredient into the mixer. The mixer is generally the next place that the medication or toxic ingredients may contribute to carryover or cross-contamination. Buildup in the mixer that might break off, mixer not cleaned out adequately, and material hang-up could all contribute to carryover. Surge bin, holding bins, and elevator legs, conveyors and boots can all be points where feed gets hung up and not allowed to free flow. Bulk drugs and toxic ingredients should be inventoried to make sure all ingredient makes it from the unloading area to the storage area. The inventory should be checked against the weight ticket of the received ingredient. Electrostatic adhesion, corners, faulty equipment, or moisture could cause the feed or ingredient to hang up and the entire amount not get to the appropriate storage area. Baggers and bulk trucks can also be areas that contribute to cross-contamination. Incomplete cleanout, bridge materials, improper, incomplete, or absence of bin records can cause errors that lead to cross-contamination. It is the responsibility of the manufacturer to make sure they have adequate procedures in place to prevent carryover. Each step in the process, each piece of equipment should be evaluated and understood for the firm to take appropriate action to minimize or prevent carryover. When receiving bulk medications or toxic ingredients, a best practice would be to have a way to measure or weigh the incoming ingredient in, and make sure that the correct amount is received in the appropriate holding area. Whether by weighing or measuring the holding area prior to and after receiving the product and comparing the amount in the holding area with the amount scaled in. For packaged ingredients, a physical inventory can be helpful in assuring the correct amount of an ingredient is received and used. The most common method used to prevent cross-contamination of feed manufacturing is sequencing. Sequencing is accomplished by following a feed containing a medication or toxic ingredient with a non-medicated approved combination feed or non-toxic feed to a similar species and class. The following feed may pick up traces of significant amounts of medication or toxic ingredients with no harmful effects on the animals or humans. Caution should be taken to ensure that the animals that receive the follow-up feed are approved for that medication or toxic ingredient. For example, if you are mixing an antibiotic for beef cattle and the follow-up feed is for dairy cattle, the antibiotic may not be harmful to the cow, but the milk will contain antibiotic which could get to humans that may be allergic to the antibiotic and become ill or die. If sequencing is used, there should be a sequencing schedule for all feeds that contain drugs or toxic substances. Flushing is using a specific amount of a single innocuous or not harmful ingredient, held out of the batch and following the medicated or toxic feed through the equipment used to manufacture the medicated or toxic feed with. The flush material may follow the feed through the system and be placed on the top of the feed. The flush material will be mixed in with the feed as it is conveyed or loaded. Flush material may be saved for a future batch that contains that medication or toxic ingredient. If flush material is saved, it should be identified as to the batch it originated from to be able to trace the drug used. Flush material may also be trashed. Physical cleanout can be used to remove medicated feed or toxic feed. The physical clean out material may be stored for future use like the flush material if the feed is not contaminated with other materials or trashed. Blowing down the equipment and removing any loose feed or ingredients, removing caked or bridged feeds are examples of physical cleanout. Most mills may use a combination of these methods depending on their needs and availability at the time of manufacture. How does one determine if their cleanout procedures are adequate? A commonly held thought is that 5 to 10% of the capacity of the manufacturing equipment can be used to flush the system as stated in Guidance Document GFI 272. What is the volume of the mixer, surge, elevator, conveyor, bagger, or bulk bin cubic feet? Take into account all the equipment to be flushed, not just the mixer. If a system has roughly 100 cubic feet of space, times 10% would be 10 cubic feet of flush material. Corn weighs about 40 pounds per cubic foot, so that would take about 400 pounds of corn to flush that equipment. Each mill is different. You should measure your own equipment to determine how much flush material you will need. The flush material you use may be determined by the type of feed you are manufacturing. A mineral mix need a denser material to flush, such as salt. A cubic foot of salt weighs about 80 pounds, so for that same equipment, you would need to flush with 800 pounds of salt. The best way to confirm that your procedures and processes are adequate is to test. You can test a subsequent batch for carryover. If you know the level of ingredient in a previous feed, do a clean out and sample the following batch to find out how much carryover is in the batch. The goal is to provide livestock feed that is safe for humans and animals. By adhering to good manufacturing practices and adequately addressing the hazards that occur in livestock food production, carryover of toxic substances can be managed to a level that is safe for the humans and animals that consume the animal food. We believe there are 4 root causes for drug or toxic ingredient carryover for the cases we have witnessed. First is a lack of adequate training. 21 CFR 507.4 states in part that the management of an establishment must ensure that all individuals who manufacture, process, pack, or hold animal food are qualified to perform their duties. They must be a qualified individual, meaning they must have the education, training, or experience necessary to perform their duties and ensure safe animal food. The second is a failure of a system to hold employees accountable. 21 CFR 507.4 2C states that the responsibility for ensuring compliance by individuals with the requirements of this part must be clearly assigned to supervisory personnel who have the education, training, or experience necessary to supervise the production of safe animal food. Supervisors or other management should review production records to make sure that procedures are followed, that all steps to prevent cross-contamination are followed, and the operator or employee is documenting cleanouts. Third is human error. Human error simply cannot be avoided. However, there are steps to take to minimize the errors and the impact those errors may have on animal food. Management should ensure that the SOPs, GMPs, and preventive controls are followed. Each step is documented and verified to ensure the steps were taken to ensure the animal food is safe for consumption. I know this sounds like a preventive control, but whether the hazard is controlled by a prerequisite program or preventive control, the steps to ensure a safe food are very similar. Fourth, failure to adequately evaluate all known or reasonably foreseeable hazards associated with an ingredient, process, or equipment. An example might be handling of bulk materials and not accounting for equipment failure, causing toxic ingredients to be diverted to an unintended ingredient or feed. We encourage all owners, managers, and employees to be actively engaged in the safety of animal food. Know your plan, know your programs, train your employees, and work together to produce safe animal food. Your food safety plan, including SOPs and CGMPs, will change over time as new products, processes, and employees change. Take ownership of your plans. Know what is in your plan and update that plan every time something in your facility changes or new information is made available. We hope that this information has been helpful in some way. To borrow a phrase from Smokey the Bear, only you can prevent animal deaths and illness from exposure to toxic feed.
Great. Dana with Kansas Department of Agriculture. We'd like to thank Deborah for recording that video for you to listen to this morning. And now, Jamie, we've had a couple questions come in the chat, and we'd like to share those with you, and we'll be able to get that answer. The first one that came in the chat was, what is the acceptable tolerance in parts per million for copper levels in sheep?
That's a really good question. There's not a real solid answer. FDA has put out some guidance material basically stating 20 parts per million. Anything over 20 parts per million, they would consider adulterated, and so if it stays under 20 parts per million, should be okay.
Oh, great. Like that one a lot with it. When Deborah was going through the video, she said that she referenced an LD50. So what is LD50?
That's a good question. So LD50 is the lethal dose that it would take to kill 50% of whatever it's fed to. So if in the scenario we talked about horses and Meninson, so the LD50 for Meninson in horses is 2 milligrams per kilogram of body weight. So if and in the scenario it kind of talked about that, but basically 300 gram per ton Meninson feed, if the horse 1,000-pound horse ate 6 pounds of it, half of the horses that ate that would die. So that's kind of basically what the LD50 is.
All right, thanks. We had another question come in on the chat that says, have they determined what was the root cause that caused some of the animal deaths in the recent events?
So I can't speak to those, some of those events specifically, just because part of it's still ongoing. But it suffices to say that we believe that there was some drug carryover that happened, and so that would, we've had several cases like that recently, and that's kind of what prompted us to put together this little program.
That's a great reason. We never want to have animals at all. We have a follow-up question on sheep and goats on the toxic. Is there toxicity from rumensin in sheep and goats, and at what level?
So I would suppose that yes, there is. probably almost anything in too large a level can be toxic. Off the top of my head, I can't tell you what that is. I can tell you that the reason that Rumensin is not approved for use in sheep feed is because Rumensin causes copper to be absorbed at a higher level. So even if you might have a low level of copper, if they're getting some Rumensin, they could become basically poisoned from the not from the Rumensin necessarily, but from the copper because they're absorbing more than they normally would.
Okay, stay on that same subject there. So when manufacturing a ruminantin feed for cattle, is it acceptable to follow with a Bobatech feed? Then with a non-medicated beef, is this proper sequencing?
No. The reason for that is Rumensin and Bobatech, even though they're both ionophores, they're different drugs manufactured by different companies, and they are not approved in combination with each other.
Okay, thank you. We've got another question that comes in. So in the scenario, if a cattle producer allows his horses to feed off the same bunk of medicated feed and the horses get sick or dies, who's at fault?
That depends. And the reason that
Oh, okay, let's
okay. The reason that depends is if the feed was manufactured correctly and the cattle producer received a label with that feed that says for cattle and has the caution and warning statements, do not feed to horses or other equine, then the onus really is on the producer if he didn't read or follow the label. If the feed mill did not produce a label that tells that guy he can't feed it to horses, even though he should know he shouldn't be feeding it to horses, there may be some, I guess, residual blowback on the manufacturer for not producing or giving the producer a label with the cautions and warning statements.
All right, thank you on that. I want to circle back a little bit just on residue, high level view on that. How much residue is too much?
That is also a good question. Because of the manufacturing equipment and how it's designed, you know, theoretically 0 is the number that we're looking for. In reality, there's always going to be some, no matter how many times you flush, no matter how many times you sequence, you're going to pick up some carryover or residue. So we've kind of arbitrarily picked a number of like 2%, 2 parts per million, somewhere in that range, because although we know that 0 is unattainable, I think that maybe 5 is too much, 10 certainly too much. So that's kind of where we have drawn the line in the sand is 2%.
Okay. The next question actually comes in nicely after what we just talked about on flush. And the question is there any need to flush Novus MFP when the next feed batch is going to another dairy, beef, cattle, or sheep and goats?
Okay, so I'm not familiar with Novus MFP. So I don't know what that is. If someone can give me a clue, that would help.
That's right. Or Brad, if you have additional questions on this and you want to contact Jamie directly after the webinar, we can sure do that as well. So we had another question come in. If you have an all beef plant, is it acceptable to have a caution statement saying, do not feed the horses?
Yes. So if any time that you're manufacturing medicated feed, and especially Rumensin or Bovatec, those caution and warning statements are required on the label. If even if it's a non-medicated feed, let's say it is for beef cattle. If you state on your label, you know, whatever Joe's beef feed for beef cattle only, that should be sufficient.
Our next question's asked, what is the likelihood that a drug-free facility ends up with ionophore residue in their products?
I would say the likelihood is low, but depending on where they get their ingredients from, there could be carryover from a facility that they get their ingredients from that may run it through part of their processing equipment. So it's not zero, but it should be really low.
Any additional questions in the chat at this time? If anyone else has a question they'd like answered while we're still logged on, that would be great. Earlier in the presentation, I dropped a couple links into for the 21 CFRs 507 and the 225 that Debbie mentioned. I also added a link regarding flushing and sequencing. So those were available for you to download on that. And so one more came in. What is considered an incidental amount per FDA?
Incidental. So I'm guessing an incidental amount of carryover or residue in a feed.
Michael, do you want to expand on that real quick in the chat?
FDA has not said, you know, they've not given a number per se. I think a lot of it depends on what the next species is. So
Okay.
if you're following a medicated beef feed with a horse feed, almost any is too much. So that's why it's a good practice to not follow a medicated beef feed with a horse feed if it's medicated with Rumensin, something like that. So if it's possible to maybe run 2 or 3 non-medicated batches and then run your horse feed, that should be sufficient. And if in doubt, test it.
So we have a question come in on what minerals can be identified as problematic in livestock feeds, which may require flushing and sequence.
Sure. Well, certainly copper is for sheep. So following a high copper feed with a sheep feed, you certainly would like to make sure that there's very little carryover or residue from that feed. So again, several batches in between of non-medicated feed would be ideal. If not, I would, do some physical clean out, make sure that everything adds up before mixing that. Other minerals, gosh, depending on time of year, magnesium could be an issue. Gosh, I don't know. There are several, but copper is the big one. Vitamins are other ones that can be either have toxic effects or there can be deficiencies as well. So making sure that those levels are correct is important.
Okay. We had another, at what point we expected or required to report an adverse health event to KDA?
That's a very good question. So I guess the required time to report is when you know that a feed has been distributed and possibly fed that could have harmful effects. So even, if a feed was sent out and someone did a records check and found out that too much of an ingredient was added, or proper procedures were not followed, such as flushing or sequencing, if a person or a feed mill can recall that feed before an animal gets sick or dies, that's the best case scenario, I guess. But and probably is not a bad idea to report that. But certainly if you know that a feed has gone out and some animals are sick or dying, you're required to report that to FDA on an RFR event. That's reportable food registry. So you'd inform KDA and FDA at that point.
All right.
So I see the next question. Would selenium be considered a high-risk mineral in some instances? Absolutely. Selenium can be deficient in some diets in certain parts of the state and the country. And then it can also in other animals be toxic. So I would consider selenium kind of a high risk mineral, depending on where it's being used. If it's being used in horses, or again, making sure that there's adequate levels in other parts of the country so that animals are not getting white muscle disease and dying that way.
Great. Well, with Jamie, Deborah, and the entire feed safety team, we want to thank everybody for spending the morning with us today. We're going to finish up this webinar, give you a little bit of time back in your day. If you have additional questions, go ahead and reach out to the feed safety team. So again, thank you very much. We appreciate your time this morning and have a good day.
Thank you, Dana.
Thank you so much.